In this video, we'll look at solving quadratic equations by factoring. A quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers such that a is not equal to 0. If a had the value of 0, then 0 times x squared would just be 0, and we would have a linear equation. The term quadratic actually comes from a Latin word, quadratus, which means to be made square. In fact, in anatomy and physiology, you'll also see this term quadratus refer to a group of muscles that have a square or rectangular outline or shape. This form, ax squared plus bx plus c equals 0, is called the standard form of a quadratic equation. And also note that a quadratic equation is called a second degree equation because the degree of the equation is 2. One method that we're going to use to solve these equations, right, to solve means we're trying to find what value of the variable makes the equation true. So to solve quadratic equations, we're going to use one property from the real numbers, that is the zero product property, that states for real numbers m and n, if m times n is equal to 0, then either m is 0 or n is 0. Think about some numbers, like 3 times what gives me 0? Well, the only way I can have that product to be 0 is if I'm multiplying 3 by 0. 0 times any number is 0. So you may be asking, why am I going to use that? Well, when we have quadratic expressions in these equations, we can factor them. That is, we can write them as a product. And so if we can write the equation as a product equal to 0, then that means that one of those factors is equal to 0. Therefore, the steps to solve a quadratic equation by factoring include 1. Write the equation in standard form, ax squared plus bx plus c equals 0. Then we will factor the polynomial on the opposite side of 0. Then set each factor equal to 0, and finally we will solve the resulting equations. I have a few examples that I want to work just so you can understand and see this property put into practice. The first one is x times 3x minus 4 is equal to 0. Well, think about the steps that we just outlined as really a checklist. The first one, it did say that the equation needs to be in standard form. The real thing I'm looking for there is that one side of the equation has to be 0. And then the next step said that we needed to factor the polynomial. Well, notice that x times 3x minus 4 is already written in factored form, right? That is a product. So if I multiply that out, then I would actually undo what I need to solve this equation. So we already have this in the form of a product equal to 0. Therefore, to solve this equation, it means that either x has to be 0 or 3x minus 4 must be 0. So one solution is 0. The other we solve by the methods that we've learned in the first section. We add 4 and then divide by 3 to get 4/3. So there are two values that make this equation true. The solution set then is 0 and 4/3 in our curly brackets. Example B, x squared minus 2x minus 24 equals 0. We have 0 on one side, and we actually have this equation in standard form. So now we need to write the x squared minus 2x minus 24 as a product. That is, we need to factor it. Well, to factor those trinomials, we need to find the factors of negative 24 whose sum is negative 2. If you need to list the factors of the negative 24 out, you can, but think with me that negative 6 times 4 is negative 24, and also negative 6 plus 4 is negative 2. The factors are x minus 6 times x plus 4, and we have that equal to 0. Now we can apply the property that says the only way that's true is if one of those factors is 0. So either x minus 6 has to be 0, or x plus 4 has to be 0. Solving, we get x is equal to 6, or x is equal to negative 4. Now we can also check, right? If I plug in the 6 in place of x, I can get a true statement. 6 squared minus 2 times 6 minus 24. And notice that this is 36 minus 12 minus 24, which is 24 minus 24, or 0. So that does check in the equation. And in a similar fashion, we can plug in negative 4 to see that that's true as well. Our solution set then is written as inset brackets negative 4, comma 6, and close the bracket. Another example, part C, is 27x squared equals 9x. This equation is not in the standard form. We don't have one side equal to 0. The first step then is to subtract 9x from each side to write the equation as 27x squared minus 9x equals 0. And now we need to factor the expression 27x squared minus 9x. This is just a binomial. There is a common factor of 9x from each of those terms. If we divide each term by 9x, 27x squared divided by 9x is 3x, minus 9x divided by 9x is 1, and then that is equal to 0. Setting each of these factors to 0, we get 9x equals 0, or 3x minus 1 equals 0. Divide by 9 to get 0 divided by 9 is 0. Or 3x minus 1 equals 0 gives us 3x equals 1 after adding 1, and then 1/3 after dividing by 3. The solution set then is 0, comma 1/3. Another example, x squared plus 11x equals negative 30. Again, this is not in standard form, so we would add 30 to each side to get x squared plus 11x plus 30 equals 0. And now we need to factor this trinomial. We want to find the two binomials whose product is that trinomial. The factors of x squared are x and x. And then the factors of 30, whose sum is 11, would be plus 6 and plus 5. Again, you can check by foiling that out to see that you get this trinomial. But now we have it written as x plus 6 times x plus 5 equals 0. The only way that this is true is if either x plus 6 is equal to 0 or x plus 5 is equal to 0. Subtract 6, we get x is equal to negative 6. And subtract 5 to get x is equal to negative 5. Writing the solutions in order from smallest to largest, we would have the set containing negative 6 and negative 5. And again, I could plug in those values to see that I get a true statement. Example E, 8x times x plus 3 equals 2x minus 5. We need to undo the multiplication and then get one side equal to 0. We get 8x squared plus 24x after we distribute on the left is equal to 2x minus 5. So to set one side equal to 0, we need to subtract 2x and add 5 to each side. This gives us 8x squared plus 22x plus 5 is equal to 0. Now we need to factor this trinomial, and we will learn what to do if the equation doesn't factor. We have to use a different method to solve those. So I need to figure out what are the factors of 8x squared and the factors of 5 that I can arrange to get a 22x. So the factors of 8 are 1 and 8 and 2 and 4. And the factors of 5 are only 1 and 5. So let's try 4x and 2x. And I'm going to try 5 and 1. 5 in the second binomial and 1 in the first. And notice that my outer and inner is a 20x and a 2x, whose sum is 22x. So this one is the correct arrangement, and I need all the signs positive. So now I have this factored, and I set each factor to 0 to get 4x plus 1 equals 0. If I solve this, I get 4x equals negative 1 after subtracting 1, and then divide by 4 to get negative 1/4. The other factor is 2x plus 5 is equal to 0. Subtract 5 to get 2x equals negative 5, or x is negative 5/2 when I divide. So in the solution set notation, I would have the values negative 5/2 and negative 1/4. And then one last example I want to work, it is the product x plus 4 times x minus 5 equals negative 8. Be careful on this one because the left side is factored, but the right side is not 0. So I can't do any funny math here. I have to undo the multiplication and set it to 0 before I can apply the zero product property. Multiplying on the left, I get x squared minus 5x plus 4x minus 20 is equal to negative 8. Right, so that was just first, outer, inner, and last. Combining like terms on the left, I get x squared minus x minus 20 is equal to negative 8. And then now I can set this equal to 0 by adding 8 to each side. And negative 20 plus 8 is negative 12, and that is equal to 0. We need to factor x squared minus x minus 12 by finding the two binomials whose product is that trinomial. The factors of x squared are x, and the factors of negative 12, whose sum is negative 1, would be a negative 4 and plus 3. Now I can set those factors to 0, so if x minus 4 is equal to 0, or x plus 3 is equal to 0. Adding 4, I get x to be 4, or subtracting 3, I get negative 3. So my solution set would be the set containing negative 3 and 4. Again, if I want to check, let's just check one of these. If I plug in negative 3, I'm asking is negative 3 plus 4 times negative 3 minus 5, is that equal to negative 8? Negative 3 plus 4 is 1. Negative 3 minus 5 is negative 8. And guess what? 1 times negative 8 is negative 8. So negative 3 is a solution of that equation.